Welcome back to another one of my learning derivatives video series where I'm going to teach you how to do derivatives, the basics. So here we've got the quotient rule, Lagrange's notation written out, and I'm going to teach you how to derive inverse trig functions or inverse trigonometric functions. Okay, so here's the rule. You should all be pretty familiar by this far into the series, but anyway, we have a function over a function, and the derivative is of this function, hx, equals the derivative of the first function multiplied by the second function minus the first function multiplied by the derivative of the second function all over the second function squared. Okay, so let's start with our first example. So here we have the inverse of cotangent of x over ex. We have a function over a function, just like when we're following the quotient rule. Luckily that we are, but we're gonna label one of these as fx and one of these as gx. Just like I did just then, we're gonna label fx as cotangent of x, the inverse, down here. And we're gonna label gx as ex. Okay? Here is the derivative following the quotient rule, and what we need to do in order to complete this is find the derivative of fx and the derivative of gx. So the derivative of the inverse of cotangent of x is negative 1 over x squared plus 1, and the derivative of gx is e to the x, because e to the x when derived is the same. Okay? So now we know this, we can fill out this equation. Okay. So, f dash of x is negative 1 over x squared plus 1 multiplied by gx, which is e to the x, minus fx, which is the inverse of cotangent of x, multiplied by the derivative of gx, which is e to the x, all over gx squared, gx being e to the x, ex squared. Okay, now we have this. First things first, simplify. Okay, we have an e to the x on this side of the minus sign multiplied, and we have an ex multiplied on this side of the minus sign. Therefore, we can factor it out, and what we're left with is as such. Okay? So if I expanded these brackets, I would get this up here. But that's not what we're going to do. We want to simplify. So we've got an ex squared on the bottom and an ex on the top. We can get rid of this, and we can get rid of 1 from the bottom. So what we're left with is negative 1 over x squared plus 1 minus cotangent inverse cotangent of x. I'm going to split this up, these fractions, just like this. See how I did that? I put an e to the x on this side and an e to the x on this side, so it's the exact same thing still. I'm just moving things around. So I've just split it. It's the exact same thing, but I've just split it. Okay? So, because we have a fraction on top of another fraction, what we can do is bring the bottom of this fraction to the bottom of the original fraction. That will look like negative 1 over x squared plus 1 e to the x. That's all good. Minus the inverse cotangent of x over e to the x. That doesn't change. But anyhow, that there is the first derivative of the inverse of cotangent of x on e to the x. So I'll get the second example out. That is 3x squared all over the inverse of cosec of x, or cosecant of x. That equals, well, it equals f over gx, because I said it does, but we have a function over another function. We have a function over another function. Therefore, if we make these equal each other, it won't affect anything. It'll just make it easier for us to solve. So we're going to call fx 3x squared, and we're going to call gx the inverse of cosec of x. Okay, so we need to find these now in order to complete this. So the derivative of 3x squared is 6x, and the derivative of the inverse of cosec of x is negative 1 over x multiplied by the square root of x squared plus 1, minus 1. Okay. So now we have all the information we need. We're going to fill out the equation. Solve the question. So, derivative of hx equals, the derivative of fx is, the derivative of fx is 6x here, multiplied by gx, which is the inverse of cosec x, minus fx, which is 3x squared, multiplied by the derivative of gx, which is negative 1 over x square root x squared minus 1. Okay, and that is all over gx squared, gx being cosec inverse x and all squared. Okay, so now we have all this, we can simplify and solve. 6x cosec inverse of x. Well, I'm going to split. First of all, I'm going to split it. So we'll have a cosec, or an inverse cosec squared on either side. Should look like this. And the top bit, I'm going to simplify this by multiplying the, well, we have a negative multiplied by a negative, so that makes that a positive. And I'm going to bring the 3x squared on top of this fraction. So what we'll have is 3x squared all over x square root of x squared minus 1. Okay, so here we can simplify. Get rid of 1 inverse cosec x, get rid of 1 on the bottom. So we'll have 6x over the inverse of cosec of x plus, okay, over here, 3x squared over x we can get rid of one of the x's. Oh, there's only one x that we can get rid of on the bottom, and we can get rid of one on the top. Also, because just like in the previous question we had a fraction on the top of another fraction, we can move the bottom part of the inner fraction onto the bottom part of the outer fraction. Now, I hope that doesn't confuse you, but what we'll have is in one big step. Basically, I'm multiplying the 2 by the negative 1, because when you have a power on another, when you have a power and then another power, or this is cosec x to the power of negative 1 to the power of 2. Therefore, we multiply the negative 1 and the 2 together. It simplifies down to this. And we have, this is multiplied on. Essentially, we can multiply it out and then multiply it back in. And that way, we'd multiply it out, multiply the 3x on the top and the square root of x squared minus 1 on the bottom, which is what we did. Okay? And there's no more to simplify. And this, well, yeah, there's no more to simplify. This is what I'm going to leave it as. Now, thanks for watching. I hope you learned something, and have a good day.